Right. How are you, my class? A level. Right. This week we want to look at question papers on mechanics. So what I'm going to do here, I'm going to help you answering the question paper. I'm not going to answer as such. I'm going to give you hints, formulas, or direction on how you can attempt this paper. Then you finish the calculation alone. But I'm going to give you a highlight on how you are supposed to answer this. So we are going to look at February, March 2020. It was component 2. So you need to understand all the instruction before you start. The time is 1 hour 15 minutes. So the instruction here the instruction. You have to answer all the questions, and you also have to have the formula booklet with you, right? So the instruction, you can read the instruction, but it is very important to know that the numerical value for the acceleration due to gravity is 10. In physics, you use 9.81 or 9.8, but here in mechanics, we use 10. You need to take note of this. And also, if a number is non-exact, your answer should be in 3 significant figures or 1 decimal place if it is in degrees for angles, right? And the paper is out of 50. The paper is out of 50, and the marks allocation are in this at the end of the question. So like I said earlier, the order on which you attempt these questions is not a mandate. You can start with 6. You can scroll down this paper and see if you can start with 5. Maybe it's easier to you. You can start with 5 because their space is given. You can start with the number 5, then you finish in a shortest period of time. Then if number 6 is easier, you can do it until you finish the paper. But in this case, we're going to start with number 1 stage by stage. So on number 1, if you are reading the question, you need to understand which concept are we talking about. We have a lorry of mass 16,000 kg traveling along a straight horizontal road. The engine of the lorry is working at a constant power. Right, the work done by the driving force in 10 seconds is 750,000 joules. Find the power of the lorry's engine, 1 mark. So in this case, as you look at the question, you could see that this topic is under work energy and power. So we will need to come up with a formula of power. What is power? Power is work done over time. From the definition of power, even it to O level. Power is work done over time taken. Then you substitute. That's why we have 1 mark. So I want you to reread the question and go and see where is your work done and where is your time. Then you just punch in your calculator, then fill in the space. I'm going to give you the question papers, then you have to fill in. Then on B, we are told there is a constant resultant force acting on the roll of magnitude 2,400 newtons. Find the acceleration of the roll at instant when the speed is 25 meters per second. Right, in this case, we have to come up again with, we have heard that the driving force, we have the driving force here. So what you need to do is to come up with a formula for power. The power you have calculated in part A, I don't know which value are you going to get, is the one that we are going to use. That is the power of the engine. So from again there is a formula which states that power is force times velocity. There's also this formula, power is equals to force times velocity. Maybe if you want to derive this formula, you can even derive it from here. We have said power is it's work done over time, right? And what is work done? Work done is force times distance, force times displacement s, then over t. Then if I'm going to separate s over t, we are going to come up with a variable that is displacement over time is velocity. So you are going to see that displacement over time is velocity. So power is the same as force times velocity. So the power of the engine, you must know this formula. Power of the engine, the power you have calculated on part A, is the same as the driving force, times your velocity, So you can agree with me that power is a driving force. The power of the engine is the driving force times velocity. So in this case now, you can now find the driving force. By saying your driving force is equal to power divided by V. We are now making your driving force the subject here. You make your driving force the subject. Power, you have calculated power in part A. Then velocity, we are given this velocity. So you just punch in to your velocity. So after finding the driving force, the question saying find the acceleration. So suppose this is our lorry. The lorry is being driven by the engine, which is the driving force you have calculated just above. This is your driving force. And there's a constant resistance, that is the force which is opposing the direction of the roll, and it's 2,400 newtons. So we want to find the acceleration of this roll. So you know the Newton's second law, it states that F is equals to ma, where F is the resultant force. So this role, there are two forces here, the driving force and the resistive force. And since the role is moving in the direction of the driving force, our acceleration will be in this direction, meaning to say the driving force is greater than the resistive force. So the resultant force in this way, it will be the driving force. I don't know which value you have calculated. I'm just giving you hints. Minus the resistive force of 2,400 should be equal to m, your mass. I'm sure you are given your mass, right? This one, 16,000. We are given this mass, 16,000. So we are going to put 16,000 here. times A. So I have said you have calculated your driving force and you put your value here and subtract with 2400, which is the resistive force. This will be the resultant force which is causing the acceleration. So here you can now make your A the subject and calculate the value of what the value of the acceleration, which is A. Now moving on to number 2, we are now moving on to number right. On number 2 here, the question is saying a particle P of mass 0.4 kg is on a rough horizontal floor. So sometimes when answering this question, you have to draw just a sketch and see if you are coming up with sense. You have to draw. We have a particle P, right? This is our particle P. This is our particle P, and it's of mass 0.4 kg. So if it is a mass, we have weight, and you know weight is mg, and m is 0.4 times g, which is 10. You get 4. So the weight is going to be equal to 4. And here we have the reactional force R. You must know that if a body is in contact with a surface, we should also indicate the forces, right? We have R. Then it is said the coefficient of friction between P and the floor is mu. So in this case, there is frictional force. If the body is moving this direction, our frictional force will be in this direction. And you know your frictional force. What is frictional force? If you are to write the formula for frictional force is equal to mu r, the coefficient of friction. So it's mu r. That is our frictional force, right? Then a force of magnitude 3 newtons is applied to P upwards at an angle of alpha to the horizontal, where arctan of alpha is 3/4. Right. So let's indicate the force P newtons here. We have a force of 3 newtons, which is applied here. We have a force of 3 newtons, which is applied here. And it is applied at an angle of alpha. Here will be our angle alpha to the horizontal, where tan alpha is this, right? I want you to take note of this. If you are given tan alpha equals to this, what you simply do, you have to draw your triangle. You have to draw your triangle somewhere. It will help you because you need to find sine alpha, cos alpha, you'll be resolving forces. Right, tan alpha, from trig ratios, what is tan alpha? Tan is opposite over adjacent. Opposite of adjacent. So in this case, our opposite is this one. Then our adjacent is this one. From Pythagoras, now we can now find this longest side. This longest side. How do you find this longest side? Using Pythagoras, we say if this side is x, we say now x squared. Okay, I want you to try using Pythagoras. You know Pythagoras. Can you please try using Pythagoras? And after trying, you are going to see that this one is equal to 5. I want you to take note of that. Can you use Pythagoras theorem to find this side and verify that it is 5? So from this triangle, we are going to come up with cos alpha. We're going to come up with cos alpha and sine alpha. That is the reason why we are given this. Because when we are solving, we'll be using either cos or sine. So you need to first of all find these values. They are very, very important. So if you are given tan alpha equals to a fraction, you have to indicate on a triangle, on a right angle triangle. Or you'll be given or sine alpha instead of tan, you'll be given sine or cos. Right, so in this case, cos is adjacent over hypotenuse. So cos alpha is 4/5. And for sine is opposite over hypotenuse, which is 3/5. That is sine. So now, on A, let's answer A. Find the time it takes for P to travel a distance of the starting point. Right, so the particle is initially at rest, meaning to say initial speed u is 0, your u is 0, initial speed is 0, and it have traveled a distance of what? Of 1.44. And what is 1.44? 1.44 is our s. So we have u and s, and we want to find t. And also we are given the acceleration. We are given the acceleration, and a here is equals to 2. So we have u, we have s, we have a, and we want to find t. We want to find t. We want to find t, time. I think now you have get a clear picture on which equations are you going to use. There are 4 types of equations that you need to know if you are given these ones. I'm going to list these equations and you are going to see which equation is suitable. Which equation is suitable? You have u, s, a, and t. Let me take you back. There are these equations. V is equals to u plus at. I don't know which one you are going to use. V is equals to u plus at. We also have v squared. I hope you remember this. V squared is equals to u squared plus 2as. We also have s is equals to ut plus half at squared. I just mentioned the few, but from these few, I think you are going to find a suitable equation. Then you substitute and you find your value of t. I hope you are going to find your value of t. Then for mu now, here in this case, you can make your mu the subject from here. You can make your mu the subject from here. You can make your mu the subject from here. So what are we saying? What are we saying? Your mu, if you make your mu the subject, you are going to see that mu is your frictional force over r, your reactional force. So how are we going to find r? How are we going to find f? We need to resolve the forces. Let's see. Here the particles is initially at rest. So if we resolve the forces, we are going to see that if we resolve this 3 with this one, it will be the same as W. So let's resolve the forces upwards. Here we will have R upwards. Here we have R. So it's R plus, if you take these 3 upwards, it will be 3 sine alpha. So I think now you now know the reason why I firstly find the value of sine alpha. Then if I resolve r and 3 upwards here, it will be the same as your weight. So this is 4. So from this equation now, you can find r. You can find r and substitute it here. Then for the frictional force, how do you find the frictional force? We use the Newton, the second law here, where we are saying the resultant force should be equals to ma. Since we have the acceleration here, our acceleration is in this direction. So if I am to find the resultant force here, the object is moving to the right. So what is my resultant force? I'm going to resolve 3. So I'm going to say, let me change the color here. So I'm going to say 3 newtons. I'm going to resolve it horizontally. I'm going to say cos 3 cos alpha, 3 cos alpha, right? Then I'm going to subtract with the frictional force because it is opposing. So this is the resultant force of the particle P, which is going, which is causing the motion. So mass times acceleration, and your mass, you have your mass, you have your acceleration, you have the value of cos alpha. Then find your F. After finding your F, you are going to substitute it here and also find R where you find it. Then you find mu. You find mu. You find mu. Right. Moving on to number 3. Moving on to number 3. Let's move on to number 3. Or let's do this. Let's do this. Let's do this. Let's do this. Right. I've given you hints on number 1 and 2. I think number 3 we are going to do it together in the class. Number 3 we are going to do it in the class. And also number 4 we are going to discuss number 4 in the class. But this number 5, I have no fun with this number 5. I want you all to attempt this. I want you all to attempt this because these are resolving of forces. You know how to resolve forces. So number 5, I'm not going to discuss anything with you. Please attempt number 5 without fail. You attempt number 5. Then number 6, we are going to discuss in the class. I'm just going to give you the hints there. The due date on the submission of the paper, it will be on Tuesday, 22 February. Tuesday, 22 February. So let's meet.